Alrighty, cool. So to get started, what are we doing today? We are starting a new topic. I think you guys were doing ratios in the last lesson. This new topic that we're starting is exponents. And so you would sort of know what exponents are from your introduction to it in grade 7. I will do a little bit of revision on that now, and we're going to look at a law of an exponent. And so what is this law? The first one we're looking at is the law that has to deal with multiplication. And when we talk about laws of exponents, it's just a rule. It's a rule that applies to something. So if I say this is the law, it means whenever this certain thing happens, this is what you have to do. Like for addition, we know when we see two numbers that are being added, we have to add them up. That's the law of addition. And so here, when we deal with exponents, our exponents also have laws. And so that's what we're going to get started on today. And so let's not waste any more time. Okay, there we go. So we have our little introduction over here, a recap, if you will. So we're looking at here general exponent information. What you guys may or may not know is that there's actually a structure to the way that we deal with exponents, to the way that we draw out exponents. So our big number, which in this case is 5, is our base. Our base is our main number. So it's our main focus. So that is what we call our base. Our base is the main number that we are concerned about. Then what you'll see is that you have a little number on the top right, and we call that an exponent. And this exponent, what does my exponent do? My exponent, and let's write it out here. My exponent tells me how many times to multiply my base. So my exponent tells me how many times to multiply my base. So for example, if I were to go ahead and if I were to write out this exponent over here, the way we say it is 5 to the power of 2, or in this case, because the exponent is a 2, we can say squared. So how would I write out 5 squared in its expanded form? Well, I know that I'm dealing with 5 as my main number, and exponents always tell me I need to multiply. And how many times do I need to multiply 5 by itself? I need to multiply 5 by itself twice. And so here is, ma'am, what is the coefficient in your exponent? In this case, there is no coefficient. Why? We only have a base and we have an exponent. If we were to have an exponent, it would be not an exponent. If we were to have a coefficient, it would be when we have something like, if I had x squared, x over here would be my base, 2 would be my exponent. And if I were to have a coefficient, what is a coefficient? A coefficient is a number in front of our base. And so this is what would be our coefficient. So in case anybody didn't know that, that is a coefficient. And so we usually only have coefficients when we are dealing with variables. And what are variables? Variables is when we have those letters instead of numbers. When we have numbers, we usually won't have what we call a coefficient because we know how to multiply the numbers with each other. So when we're dealing with variables, we'll have a coefficient. And so that is where our coefficient would be. It's the number that's in front of our variable or in front of our base. And so when we're looking at this, what you also should know is that this whole thing all together, we call it a power. So in case you didn't know, a base plus its exponent together, we call it a power. So when we're dealing with exponents, there's 3 things that we are concerned about. We can actually talk about 4. We are concerned about my base. We are concerned about my exponent. We are concerned about the power. And what is the power? The power is the combination of all of it. and we are concerned about my coefficient. And so what is the coefficient? The coefficient is the number that will be in front of my base. And how do we deal with this? What does all of this mean? My exponent tells me how many times I need to multiply my base by itself. So, and so let me actually fix that over here in that my exponent tells me how many times to multiply my base by itself. So I'm not multiplying it by random numbers. I'm multiplying it by itself. And I think you guys know this. So 5 times 5, I can write this as a power that looks like this. And the way we say that is 5 squared. What if I had 2 times 2 times 2 times 2? Can somebody tell me what my power would look like? I know it might be a little bit difficult to write in the chat, or if somebody wants to raise their hand, that would be great. There we go. Bree, I see you did that perfectly. We're going to have a base of 2. Well, how did I know 2 was my base? Because that's the number that I'm multiplying by itself. And to the power of 4. Why? I multiplied 2 to itself 4 times. So that's great. Now, let's look at something a little bit trickier. What if I had something like 2 times 2 times 2 times 3 times 3? What would my answer to this be? Let's see if anybody can tell me in the chat. Itandile, I see your hand up. Are you putting your hand up to answer the question?
Yes, ma'am. So our
Yeah.
answer would be 2 to the power of 3 times 3 to the power of 2.
Exactly. Thank you so much. 2 to the power of 3 and 3 to the power of 2. How did we get this? I knew that I could take all of these 2's together and I could multiply them together to give me 2 to the power of 3. And then I knew that I could take these 3's together and it could give me 3 to the power of 2. And what was I left with? Do you see that after I did that, there was this little multiplication left over? And Itandile, I think you can say that's how we went and we carried it over into our answer. Did you use a different method? Did you understand it differently, Itandile?
No, ma'am, I just did the same thing you did.
Exactly. So usually what happens is it kind of happens subconsciously. We don't even realize that this is a method that we're using, but this is how you need to think of it. And I see you say because they aren't like terms. Um, like terms we deal with mostly when it comes to dealing with variables. But in this case, I could have multiplied 2 times 3 and I could have said, okay, that's 6. But just when we're dealing with exponents, I know that all my 2's can be condensed into its exponent form and all the 3's can be condensed into its exponent form, but I'm still multiplying them to each other. Okay, and then one more. Let's see if I can trick x times y times y times x times y. Does somebody want to tell me what that would be if we were to write it in exponential form? Okay, I'm gonna give Mateo a chance.
Evening, ma'am.
Evening, Mateo. Am I saying your name correctly?
Yes, ma'am, you are. So, ma'am, it's x to the power of 2 times y to the power of 3.
Exactly. Can you tell me how you knew that? How did you do that?
Ma'am, because I saw like which variables are the same, and then I saw, okay, so there's 2 x's, so then I said x to the power of 2, and there's 3 y's, so I said y to the power of 3.
Exactly. Thank you, Mateo. And so what I want to point out to you guys over there is that just because they aren't next to each other doesn't mean we can't move things around. Remember, when we're dealing with multiplication, saying 2 times 3 is going to give me the same answer as saying 3 times 2. So when I'm dealing with multiplication, I can move stuff around to make it easy for me. So if I didn't know, what I could have done is I could have then moved all my like terms, as we call them, together, move all my terms that are the same, so moved all my same variables together, and I would have seen, okay, look, x times y times x times y is the same thing as saying x times y times y times y. And from there, it would have been easier for me to say, okay, there's 2 x's and there is 3 y's. So you guys seem to be happy with this, our general, how we deal with our exponents. Is there anybody that has any questions on this before we move on to this law that we spoke about? Any questions? You guys can give me thumbs up in the chat, a thumbs up in the chat if you're happy with this, if you feel confident, if you know what's going on here. Or you can give me a thumbs down if you're like, ma'am, I'm so confused. I have no idea what's going on. Okay, I see some thumbs ups and I don't see thumbs down, so I'm gonna move on. Let us look at our first exponent law. And so you see here, I've labeled it exponent law 1, and it deals with multiplication. And what is my rule? My rule tells me when you multiply powers, and let's remember what a power is from this little activity we just did up there. When we multiply powers that have the same base, so let's think about it. So when I have a power and my base must be the same, so that main number, that main variable must be the same. What do we do? When I have powers with the same base, I have to, and let's use a highlighter, I have to keep my base the same. And then what do? I add the exponents. So let's look at how that would work in an example. In this case, you'll see here we have a to the power of m times a to the power of n. And so my exponents aren't the same. My exponent over here is m, and my exponent over here is n. I see your question, Brie. I will answer it as soon as I'm done here. So my exponent is m and n. I don't have the same exponents, but my law didn't say I need to have the same exponents. My law said I need to have the same base. And if I scroll back up quickly and I look at what my base is that main number. It's that big number. And so when I go ahead and when I look at it, I see, okay, wait, I have A and I have A. Those are the same. And so that means when I have same bases, as soon as I have the same bases, and what was the other important thing? The other super important thing to know is that you have to be multiplying. And so I am multiplying over here. So this is how we know. When you know you can apply law 1, you have to have the same basis and you have to be multiplying them. And then if those two criteria are met, boom, you can apply law 1. And what does law 1 say? Law 1 says, when you apply law 1, what do? We keep the base. So here our base was A. So look at our answer. We kept our base of A and we added the exponents. And so here we went m plus n. And so that's just a general idea of what it would look like. If I had something like, let's say, what can we say? Let's go with x squared times x cubed. Let's look at this. Can I apply exponent law 1? I first need to see, am I doing multiplication? Yes. Are my bases the same? I see a x and I see a x. So immediately I know, okay, now I'm going to apply law 1. And what does law 1 say? Law 1 says, add my exponents and keep the base. And so my answer over here is going to be x and 2 plus 3, and that is going to give me x to the power of 5. And so what if we don't have the same base, as Brie has told us? What if I have something like x squared times y squared? Am I doing multiplication? 100%, yes, I'm doing multiplication. But do I have the same bases? No, I don't. And so, what does this tell me? I can't apply law one. And so my answer is just going to sit as it is, as that. I can't simplify this anymore. This is my answer. And you'll see that's kind of what happened up here. I was left with my answer here as x and y and x and y. So when I have multiplication, but my bases aren't the same, there's nothing more I can do with that. That's my final answer. Bri, I hope that answers your question. If you still confused, let me know. Okay, Mateo and Itandile, I see your hands are up. Are they up to ask a question or were they just up from answering? Okay, great. Thank you. And so this was our explanation of the law. Let's go ahead and let's actually try some examples, and you'll see it actually can get quite tricky. Okay, great, Bri. It can get quite tricky. I know it seems easy now, but once we start putting more stuff in, it's kind of like, okay, how do we do this? And so let's look at it. Easy ones first. A squared times a squared. Does someone want to help me? Utandile, you're so fast. Okay. Yes. Do you want to help me with this?
Yes, ma'am, I do.
Okay. What do I do?
Ma'am, the rule is that if our bases are the same, we keep our base, which our base is a, and then
Okay.
we add our exponents, which is 2 plus 2, which is, and then we write it down, and then our next step is a. Then you say 2 plus 2, which is 4.
Good job. And I don't even need to add any more to that because Itandila, you explained it beautifully for us. Thank you for that. And that's it, guys. That is it. Are we doing multiplication? Yes. Are we multiplying the same bases? Yes. If we are, we apply law one, and law one says keep your base the same and add your exponents. And so that's what Itandile did. Thank you so much. Let's move on to something a little bit more tricky. So I don't want us to look at stuff that's going to confuse us. So, any takers for this? Itandile, your hand is still up. If you don't put it down, okay, we have Mateo. Mateo?
Yes, ma'am. Ma'am, so I think you say 2 times 3, which equals 6, and then
Okay.
you keep the coefficient a, and you just put the 2, I think.
Okay, so let's look at this. Firstly, multiplying your coefficients, brilliant, love that. So what I just wanna, Itandile, don't know. Mateo, don't go away. I'm just
Okay, ma'am.
explaining this thing super quickly. We have S in V. And so what you guys should use that is super helpful is this little acronym. So when we are dealing with exponents and variables that have coefficients, what do? We always deal with our signs first, then our numbers, and our numbers are usually our coefficients. And then we deal with our variables. So in this case, what did we do? Let's look at what our signs are. Our signs here for both my terms are positive times a positive. And so that gives me a positive. So I knew, okay, my answer was going to be a positive answer.
Yes,
Let's
ma'am.
deal with our numbers. And then, Mateo, you did that beautifully. My numbers here was 2, and it was being multiplied to 3. And you told me keep the 6. Cool. Then, Mateo, what I also want to tell you is just a little bit of a correction on your terminology. You said we keep the coefficient of A. Now, what I want you to remember is 2 is my coefficient and 3 is my coefficient. A what would A be, Mateo?
A variable, I think.
It is a
Ma'am?
variable, but in terms of exponents, what would it be? Is it my exponent? Is it my coefficient? Is it the power? Is it the base? Which one is it?
Yeah, ma'am. I think it's No, it's not a coefficient. Ma'am, I'm not sure. I just know it as a variable.
Okay, it is a variable, you're right. But in the context of my exponents, so the other way you can think of a base is the base is the thing that our exponent is attached to. So look at it, the exponent here of 2. 2 is attached to a, right? And so a is what we call our base. So we keep our base. So we keep our base of a, as you said. And what do? We have to go and add our exponents. So now, Mateo, can you tell me what are my exponents?
2.
Okay, but what about this exponent here? Is there an exponent that should be there?
Ma'am, I don't think so.
Okay, what I want to show you is, doesn't x, just as a x, doesn't it have an exponent of 1?
Oh, ma'am. Oh.
So remember,
Yes, ma'am.
every number has an invisible, and that looks like an N, but every number has an invisible exponent of 1. So, Mateo, do you want to try that again for me and tell me what my
Yes, ma'am.
exponents are?
Yes, ma'am.
Mm-hmm.
It's 3.
It's 3. How did you get 3?
Because ma'am is add 2 and 1, ma'am.
Yes, so you added 2 and you added 1, and we were left with 6a cubed.
3.
You happy with that?
Yes, ma'am. Thank you so much.
Thanks, Mateo, for answering. And so, as we see, we dealt with now our variables, and our variables was a squared multiplied by a. And remember, a had the invisible exponent of 1. And so when we multiplied that, we got a cubed. And look at, if we combine all of this, we have a positive answer. We have 6 as my coefficient, and I have a cubed. And so this is the method I want you guys to use. Always use SNV. You always multiply your signs first, then your numbers, which is your coefficients, and then your variables. Let's try another one. Okay, this one shouldn't be too difficult. Anybody who wants to answer that is not Mateo or Itandile? In the chat is fine also. No, okay. Mateo, I see your hand still up. Itandile, I saw you put your hand down, but if you still want to answer, you can put it up. I'll give you a chance. There you go. Okay, Itandile, how do we do this?
Ma'am,
Mm-hmm.
I'm gonna say x. Since our coefficient, our power is our base is x, we leave x, and then we see if we are since our exponents are going to be 12 and 8, we're going to plus our exponents, which is going to be 20, which is going to be x. 12 plus 20 plus 8, which is at the bottom, is going to be x to the power of 20.
Great job. And I see Bree got it in the chat as well. Well done, Bree. Thank you, Itandile. Let's move on to something a little bit more tricky. Okay, ignore this brain break, everybody. We're not at our brain break yet. Let us look at this. Itandile, Mateo. I don't know which one of you to give a chance now. Okay, let us try. Mateo, you're saying you, please. Fine, I think that's fair. Itandile answered the last one. Ask to unmute.
Okay, ma'am. So yeah, ma'am, you're supposed to multiply the Wait, is I keep forgetting the variables,
Mm-hmm.
which is obviously x, and then
Mm-hmm.
you say 3 times 4, which is 12. So you're gonna say x to the power of 12.
Okay.
Then
Remember, what does law 1 say? What does my law 1 say? Keep the base, and what do I do with the exponents?
you add the x. Oh, my days, why do I keep
Add,
doing this? Keep it.
add the
Plus,
exponents.
it's
That's okay.
7. Sorry.
It
Sorry.
is 7. How did we get that? We
7.
went 3 plus 4. Okay, and then what?
And then, ma'am, you times.
Mm-hmm.
Oh, ma'am, 3 plus 4 is 7. And then you times y. 2
Mm-hmm.
plus 6 is 8. So you say y times y is y, and then 2 plus 6 is 8. So then you say x7 times y8.
Good job.
Yes,
And
ma'am.
you did that super quickly, understood everything. Good job, good job. So yeah, this didn't trick you at all. If anybody is a little bit confused, let's talk about it. So remember what we did up here. I can condense expanded forms into exponential form. So by the way, when we write it out in multiplication, we call that the expanded form. And when we condense it into its exponent form, into a power, we call that exponential form. So I can do the same thing here. I wanted to condense this into exponential form. And so what did I do? I saw, okay, my law says when I have multiplication, and so let's use that orange highlighter again. I have multiplication all over, but it says I can only apply law 1 when I have the same base. So I see here's x and here's x. So I can apply law 1 over here. And what about the rest of it? Well, I see y and y have the same base. So that tells me I can apply law 1 over there as well. And so what we did is we treated it as 2 separate applications of law 1. And what does law 1 say? Law 1 says keep our base. So what we did is we kept our base of x and we added our exponents. So 3 and 4. And in the next part of it, what did we do? We kept our base, which was y, and we added our exponents, which was 2 and 6. And what happened with this little multiplication that never fall into my law 1 brackets is we just brought it down. And at the end of it all, I'm left with x to the power of 7 multiplied by y to the power of 8. And now can I apply law 1 again? No. Why? Because my bases are not the same. I do have multiplication, but is x the same as y? No. So that's where it stops. Okay, if anybody has any questions on that, also screenshots. I don't know if anybody was taking screenshots or needed screenshots, but I suppose now would be a good a time as any. So just a few seconds here. Okay, moving on. Then we have this little law that we need to remember. And then let's look at some of the examples that we did. Moving on, and I think this was the last. Okay, cool. So then, before we get to our brain break, I want to move this. I hope I didn't like ruin everything, but we'll see. Okay, last one before our brain break. Any takers? Anybody that wants to try this? Itandile, your hand is up. You are super brave.
So, ma'am, I'm laughing.
Uh-huh.
So, ma'am, I don't know what I did, but then I hope it's right.
That's
Ma'am,
okay. Mm-hmm.
we have unlike terms, unlike bases. So, ma'am, we're gonna say x
Mm-hmm.
xy
Okay.
plus 13 to the power of 13
So
plus
xy to the
12.
power of 13, like that?
Yes, plus 12, ma'am.
Okay, let me stop you there. Let me stop you there. Let me give you some very, very useful information. Think about when we have something like x, y. What does that mean? Doesn't that mean x times y?
Yes, ma'am, it does.
And think about when we have something like 3x squared. What does that mean? That
That's
means
3 times
3
x.
times x squared. So let's do this. Let's write this out as x to the power of 13 times y to the power of 12 times 6x to the power of 8 times y to the power of 30 and times 2x to the power of 3. So we've expanded it now. So all that we did is we broke up the terms into individual little multiplication sums. So now, Itanile, I want you to try and apply law 1.
Okay, ma'am. Now I can apply the one. So,
Mhm.
ma'am, we're gonna say, wow. Okay,
Mhm.
we're gonna say, x it's x plus 13.
Okay, so x and then 13.
Yes, ma'am.
Mhm.
I'm so afraid. Times
Mhm.
y
Mhm.
12
Uh-huh.
12 plus 30.
Plus 30.
Yes, ma'am.
Mhm.
Times 6 times 6 and times 6 times 2, which is 12.
Okay. Yes, you're on the right
Ma'am,
track.
don't laugh. Ma'am, don't laugh.
I'm laughing because you're so hesitant, but you're doing the right thing. Don't be so hesitant. Just go for it.
Then it times x plus 8
Mm-hmm.
to the power of 8 plus 3.
Exactly. Okay, I see something going on in the chat. Let us look at it. Mateo, you are saying 6 times 1 times 2. Yes, great stuff. And that's why I wanted to tell you, Itandile, let's go SNV. It'll make your life so much easier. So look at our signs. What are the signs of our 3 terms up here?
They positive, ma'am.
They're all positive. So it's positive times positive times positive, which gives me a positive. Now, look at your numbers. What are the actual numbers that you have there?
Like how, ma'am, are they base or exponents
So the
or?
coefficients. Remember, when we talk about numbers, we're really talking about our coefficients.
Okay.
What are our
Okay.
coefficients that are actual numbers?
They 6 and 2.
6 and 2. And what does that give us?
12.
12. And now let's deal with my variables. And the variables, we have x variables and we have y variables. So let's go x and let's go y. And then it's x to the power of 13. So x to the power of 13, x to the power of 8. Oh, that's wrong. X to the power of 8 and multiplied by x to the power of 3. You with me so far, Itandile?
Yes, ma'am, I am.
So this, what you were doing is not wrong. And if you were to carry on, you would have gotten to the exact answer. But this, when you use this SNV method, it gives you so much structure. So you don't feel like you're just like, wandering around doing whatever. here, when we do this method, we have structure. It feels more comfortable. I'm like, okay, I know what I have to do. I know what I'm doing. And so those are all my X variables together. Let's do Y. It is then Y to the power of 12 multiplied by Y to the power of 30. And so you kind of did that for us already, in that you said this would be Y 12 plus 30. And over there we had our X 13 plus 8 plus 3. Okay, let me turn off annotation. Give me a second. I know you guys are all seeing that. Don't get excited. I turned it off so nobody scribble on my board. I think I will give everybody a chance to draw on the board, but let's finish our lesson first. And so as we see now, we have some structure. So what I'm going to do is I'm going to erase what we've done over here, and I'm going to redo it in a nice little structure that we have. So I'm going to say 6 times 2. This question left you baffled. Okay, I don't know if it's Shady. Is your name Shady? Is that how, is am I saying that correctly? Let's look at what's happening in the chat. It left you baffled. Itadile, don't lie. You weren't baffled. You got it. And is the answer 12 x to the power of 27 and y to the power of 42? We'll see. I know 12 is correct so far. So we have 6 times 2, and then we're applying law 1 with all of our x's. And what is the law? The law is keep the base, and my base is x, and add my exponents. And Itandile, what were all my exponents for my x's?
Ma'am? Oh, your x's exponents would be... Very sorry.
That's okay. It's on the board as well. I wrote it there.
It'd be 24.
Oh, you're adding them up for me already? Okay, great. Let's do the addition first. And what are the exponents I'm adding for my y's?
It'd be 12 plus 30.
12 plus 30. And in my final step, let's add everything up. 6 times 2 is what for me, Itandile?
It's 12, ma'am.
12. Then I still have a multiplication. And then x, 13 plus 8 plus 3.
It's 24, ma'am.
24, good job. And then I still have my multiplication and add up my y exponents.
It's 42, ma'am.
42, good job. And we could leave our answer as this, but why this kind of looks ugly to me. I know I can remove these multiplications and I can just write my answer as 12
1x
x
to the power of 24, y to the power of 42.
Yes. Okay, Tandile. Was this question actually that hard?
Ma'am, it wasn't hard, ma'am, but then it left me baffled.
Right. I get that because it wasn't like all together and things. It was like just different, you know. But we can still apply law 1 as long as we're dealing with multiplication. Don't be afraid, you guys, to move things around when you're dealing with multiplication, because remember, when you move the order, when you change the order of your multiplication, it doesn't matter. And so Mateo, you had the answer long ago in the chat. So that's great. For anybody who was confused about this question, I hope that it makes sense now. I'm giving you guys also a second to take a screenshot of this. I also want you to notice how we can get the answer without using SNV, without using sign number variables, but it kind of leaves us like, I almost want to say waffling, like we're just like going with the wind and letting the wind take us wherever, and it's like, did I do this? Am I supposed to do this? Let's give ourselves some structure. Let's do signs first, numbers next, variables last, because it's easy like that. And now for our brain break. Okay, guys, we're dealing with one must go. So we have 4 options. From these 4, what would you guys get rid of forever? We have a bed, a pillow, a blanket, and a couch. Zach, you're saying pillows. I cannot believe it. Bed. Itanile, where are you going to sleep? That's my question. Hey, Shady, you said you've got it now. I love that. Pillows, bed. I can't, nobody's saying a couch. Guys, you're gonna sleep so uncomfortably without a pillow, without a blanket, without a bed. We can do without couches. We can just put a bed in front of the TV, if anything. Okay, I see hands up for the brain break. You guys are more than welcome to share your thoughts with me. Itandile, I've unmuted you.
Ma'am, I will sleep on the couch. I will get rid of the couch. The bed can go. The bed can go. The couch with the blanket, television. I'll be fine. You can leave me for days there.
But why couldn't you just put a bed in front of the TV? Isn't that better?
No, man, it's not comfortable. The bed's not comfortable. Bed's not comfortable. For me, that's my take. The bed's not comfortable.
Okay, Itandile, I don't agree with you, but let's see what Mateo has to say. Bree, you sleep nice without a pillow. I can't believe that.
Ma'am, I didn't even know my hand was up. Like,
Oh.
oh my God. But I'd have to remove the pillows, ma'am, because I need my bed and I need my couch. So,
Well,
it's
I don't
fine.
understand. What are you guys doing on couches that you need couches so much?
Because, ma'am, you can't watch TV without a couch.
But just
It's
put like just
abnormal.
put a bed there. If you don't have couches, just put a bed there, you know?
All right, ma'am.
Thanks, Mateo. Anybody else want to answer? Okay, well, let's go to the next one. Anybody want to answer this next one? Take the pillows from the couch. The pillows won't have, no, the pillows won't have a couch. The couch won't have pillows if there's no pillows. Okay, guys, our next one is cake, ice cream, cookies, and pudding. Ice cream. Yo, Mateo, that was quick. Pudding. Itandile says nothing. Itandile, one has to go. That's the name of the game. One has to go. Pudding. I would also say pudding, but I kind of, when I think of pudding, I also think of chocolate mousse, and like I love chocolate mousse. So I don't know if I could do that. Is that another hand I see? Itandile, your hand is still up. Are you answering my brain break?
Ma'am, none of this is gonna go. Not one. Even though I can get rid of the cookies. I don't like cookies. I don't know how, but then at some point I don't like cookies. But then at least, but then nothing has to go. Nothing has to leave.
I feel the same. I also wouldn't want to get rid of any, but if one had to go, I don't know. It's hard. Because I
It's
think of
hard.
like malva pudding. Like that's good. Does that count as pudding? I think so.
Yes, it does kind of put in.
Yeah, so I also don't know what I would do. But if I had to pick one, I'd say maybe I'd also agree with Mateo and say ice cream, but I don't know.
Ice cream? What ice cream? I don't like ice cream.
One, I had to pick one, you know.
No, I would get rid of vanilla ice cream. Like, no, listen, people who like vanilla ice cream, I wonder what rock y'all live under. It's my take. People may hate me. I only like chocolate ice cream. So, guys,
Okay, thank you. It's unclear. We see you don't want to get rid of anything. That's okay. We have the next one, guys. It is comfy clothes, a midday nap, homemade lunch, or snuggling with a pet. Personally, as a person that doesn't have a pet, I'm gonna get rid of snuggling with a pet. Zach is saying midday nap. Um, if anyone wants to share the answers, you can raise your hand. Are you saying what to my answers, Zach? Oh, I'm so sorry, Mateo. Honestly, mine too. I had a little doggy and then it passed away. And so, yeah, I'm gonna have to get rid of snuggling with a pet because I don't have a pet anymore. Breathe with me. I think anyone who says snuggling with a pet doesn't have a pet. That's my take on that. Tandile doesn't want to get rid of anything again. Yeah, homemade lunch. I thought I could do it, but then I thought about having like takeouts the whole time. Like takeouts is good, like I could have takeouts maybe like 4 times in the week, but every day, I don't think so. Yeah, and napping. Who is getting rid of napping? I saw some of you saying you'd get rid of naps. You guys are strong. You guys are strong, stronger than me. Last one before we carry on. Um, what are we getting rid of here? Oh, and let's move my text box over here. What are we getting rid of? Personal favorite outfit, favorite morning beverage. Itandile, come on, let's pick one. Your favorite meal, your favorite song. Here's my theory, okay? I can get rid of my outfit because there's like so much clothes in the world. Like I can develop a new favorite outfit, you know? I'm not like that attached to my clothes to give up a meal or a song or a drink. And Montayo, that's what I was gonna say. For those of you who don't have a favorite morning beverage, then let's just think about it as your favorite beverage. So yeah, let's not let you guys cheat because you don't have a morning beverage. It's just your favorite beverage. Your favorite beverage. So if your favorite beverage is, I don't know, Prime, Oros, tea, coffee, you're giving that up. Bree doesn't have one. Nice. I also love mojitos. I love mojitos. And, even as a grown person, I always drink the virgin mojitos because, I don't know, it's just sweeter and nicer. Fave meal, yo, Zach. I think you're the only person who chose favorite meal. Um, okay, guys. Nobody. Oh, Ethan, you guys, your hand is up, but I feel like we answered this, but you get a minute to tell us about what you would give up here.
Ma'am, I wouldn't give up anything. But
You
then for
have
those who don't
to.
have a personal favorite beverage in the morning, you're drunk. No way. Mine is coffee. I literally love coffee. In the morning, I wake up, I drink coffee every day for me to get started in the morning. But then for y'all who don't have personal favorite beverages, no, guys, no. No way.
Bree
I
put
don't
her
know
hand
how
up
I'll
so
do it.
quickly because she
No,
doesn't have
no
a
way.
favorite beverage.
No way, guys. Please bring in the favorite beverages. Come on, guys. Make favorite beverages in the morning. Come on,
Let's see what
Mateo.
Bree
No.
has to
I can see your
say.
comeback. Mateo, I don't know what coffee you drink, but then coffee tastes nice.
I
Coffee tastes
agree.
nice. Thanks, Zach.
Yeah, I
Thank
agree.
you, Zach.
Let us see what Bree has to say super quickly. Bree, yes.
Hi, ma'am.
Hi,
Personally,
Bree.
in the morning, I'm always in a rush. It's either that or I take hours to get out. So I
Same. I'm
don't
always
have
late in the
time
mornings.
to have a favorite beverage, or I just grab water and leave.
Okay, but let's just say what if it isn't a favorite morning beverage? Do you just not have a favorite beverage at all?
I'd say juice, like orange juice.
Okay, so if it
Yes,
was just favorite beverage, would you still give up the favorite beverage?
yes, I would. Time
Brie,
out of
I'm gonna
my
have
day.
to disagree with you there. Yeah, clothes. I can't, nobody really said clothes. Nobody wanted to give up their clothes. I can't believe you guys. I cannot believe you guys. Okay. I think that's it for our brain break. Thank you, Brie, for sharing with us. I agree. I also don't have a favorite morning beverage, but just a beverage in general. I wouldn't give it up. I would not give it up. Um, okay, I am going to lower hands super quick because we are starting with more examples. Again, when we look at this one, it's not too bad. Let's always remember I want to deal with my signs, then my numbers, then my variables. Firstly, am I doing multiplication? Yes. Do I have the same bases? Yes. Now I know you might say, but there's a 3 over there. But that's okay because if you go back up, and I hope everybody screenshotted this, if you go back up and you look at it, my coefficient, this little guy over here, my coefficient is not my base. X over here is my base. So my base and my coefficient are two different things. My coefficient does not change my base. Just because I have a coefficient of 2, it doesn't change the fact that my base is x. So yes, looking at this, we have my signs. Firstly, my signs are positive and positive that are being multiplied, and that's going to give me a positive answer. Let's look at numbers. And remember, the same way that every number or every variable has a invisible exponent of 1, it also has an invisible coefficient. So let's write that over here. Every number has an invisible coefficient of 1. And so let's look at what my numbers are, knowing that there's an invisible 1 over there. My numbers that I'm multiplying, it's 1 and 3, and that's going to give me 3. Let's look at my variables now. I'm multiplying x to the power of 4 and x to the power of 9. And I know those are the same bases, so I'm going to keep my base because law 1 told me to, and then it told me I need to add my exponents. And so let's do that in my step over here. So I'm going to go ahead and I'm going to say my answer is going to be 3 times 1, x, 4 plus 9. And my final answer over there is going to be 3x to the power of 13. So you can screenshot now while I move on to the next one before we close off. Also, if anybody has any questions on what we've done so far, now would be the time to ask. Oh, I closed the chat. I'm just you guys with a break, free, no way. Okay, cool. So moving on to our last one, let's look at this. Remember, looks tricky, it's not. Am I dealing with multiplication over here? Yes, I am. How do I know that I am? We know our brackets mean multiplication. So, okay, Mateo, I see your hand up. Let's try and do this before our 2 minutes of the lesson end. Yes, Mateo.
Ma'am, so first you're gonna say -2 -3. -2 times -3, which is +6, times -4, which is 24.
Why is it -4?
4, which is 24. Sorry, ma'am.
So it's a
Sorry, ma'am.
negative times a positive,
Positive.
which gives us, what did you say?
24, ma'am.
No. So let's do SNV. We're dealing with my signs only. Look at what I've written on the notes. We have a negative times a negative gives me what?
A positive.
A positive. And then I have a positive times a positive, which will give me what?
A positive.
A positive. So I know my
Yes.
answer is going to be a positive answer. Let's deal with the numbers now. What are my numbers? What am I multiplying?
-2 times -3, which is -6.
Oh.
6 times 4, which is 24, ma'am.
Okay, so it was 2 times 3 times 4. Why am I not taking into account the signs? You were 100% in saying -2 times -3 times 4, but I already dealt with my signs over here in my
Yes,
sign
ma'am.
little portion of it. So when I'm dealing with my numbers, I can ignore the signs now and just go 2 times 3 times 4. And what did you say that gave me?
24, ma'am.
2 times 3 is 6, 24. Good job. And let's look at our variables. What there?
Ma'am, so you're going to say 1 plus 1 plus 3,
1
which
plus
equals
1 plus 3. Good job.
4m, which equals 5.
Okay.
And then, wait, am I right? Okay, yes. And then for n, you're going to say 1 plus 2 plus 1, which equals 4.
Good job. N to the power of 4. So what I was just doing the SNV on the part for everybody watching. Mateo, I know you got it super quickly over there. But yeah, so let's deal with our signs. If we're confused and we don't know how to do it, deal with your signs first, then your numbers, then your variables, and then we can do it as fast as Mateo did it. And he said, okay, we're gonna have a positive answer. It's gonna be 24. We're gonna keep our base, which is the
Yes,
same,
and 5.
and we're going to add up all of my exponents. Then we have another base that's the same, and add up all my exponents, and we're going to end off with 24m to the power of 5 and n to the power of 4. Thank you, Mateo, for answering that one for us.
Thank you, ma'am.
Okay, guys, and then that brings us to the end of our lesson.